get into the big topic of open source, something that we actually say at Red Hat.
We haven't
This is so
we
awesome.
are an open culture that believes
It's actually
in
a big
employee
piece
What is that process that a developer, or let's say a
As the
developer-
Kubernetes ecosystem really boomed,
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am the host, Andrew Sullivan, Technical Marketing Manager. I guess now I'm a manager for the stream, and I am joined, as always, by my co-host, Mr. Johnny Rickard. How are you, sir?
Hey, I'm good, man. How are you?
I can't complain. It's I was just giggling a little bit because I watching that intro movie or the little thing about the live streaming. There's one of the little clips is of me. I always think like they must have like made me look thinner or something on that thing. Either that or I've like, the COVID-25 has hit me harder than I expected because but
It's a COVID 50 in the South, if you ask me.
But yeah, anyways, it's mid-July. It's hot kind of everywhere right now, I guess, at least in the Northern Hemisphere. Our two guests today are both over in Europe. We'll introduce them in just a moment, but it's hot. You're in Texas, and I think it's always hot there. I don't know that
it's always.
Yeah, and even when it's cold, it's still just it's Texas. Anyways,
exactly.
So summer doldrums. I was gone last week. Congratulations on the show. I didn't watch the whole thing, but what I saw was really, really good. So.
Yeah, Reese is a great guest, man. He came on and just kind of took control, let it happen. He's got so much good information though, so it was easy to you just ask a question. He's just got so much, and he could just answer a bunch of things. So it was great to have him on.
Yeah, I was. You and I talked beforehand, of course, and I told you I'm like Reese is easy. It's I can say the same thing about our two guests today, right? Y'all are easy. We don't have to like extract information from you. We don't. It's you're happy to volunteer it. So. Summer doldrums. Last week I was in training, Crucial Conversations, which it's always fun to me to go to those things because it's manager training, right? I'm a new manager and all that, so it was always it's interesting to go because it's reassuring, right? Because it gives you this framework to kind of repeatably do things that have always come intuitively, as opposed to like happening on it by chance or at least for me, like I didn't know that. Like I feel like I should have known that about my employees or how to work with my employees or something like that. Instead, it's been nothing new, nothing earth shattering. Just here's how to do that better, or here's how to do that repeatedly. But I guess I should take a moment to mention that we'll be off air next week, which is partially my fault and partially the world's fault. So I'll be we'll be having our offsite, our first face-to-face offsite. Everybody of the whole extended teams is coming together here in Raleigh. So I will be unavailable for our topic next week, which it's a really important one and it's a really fun one. So we wanted to make sure that we had the whole team available here. And that's talking about hosted control planes or hypershift. And we'll be joined by Adele. So Adele Zaluk, who has been on the stream before.
Yeah, he came on for the nested containers.
Yep. Yeah. Or no, it wasn't nested container. It was sandbox containers.
Sandbox.
There we go.
Yes, thank you, Jesus. Yeah, it was going to happen.
76 episodes in, Johnny. We're it's okay if we forget one or two.
Oh man.
All right. Well, hello to our audience. Thank you everybody for joining us today. We really appreciate it. Taking time out of your day. So this is one of the Office Hours series of live streams here on Red Hat Live Streaming, which means that we are here for you. Whatever questions are on your mind, whatever things that you might have that you want to ask us, that's our job here. So regardless of the topic, feel free to ask those questions in chat. We'll do our best to answer those questions. If we can't answer them here on the stream, then we'll follow up and maybe in the next stream or via blog post or social media, whatever that happens to be. We're happy to get those answered for you. If you're not watching us live, we know that there's a bunch of folks who watch the recorded streams on YouTube and all that other stuff. feel free to reach out to us. So you can reach me via email, andrew.sullivan@redhat.com. You can reach us on social media, Practical Andrew, all one word, across all the various things. So whether it's Twitter or Reddit or all of that, everywhere that there is social media that's known to me. And then, of course, the same for Johnny as well. Jonny, Jonny. If I don't mumble my words here, or my at redhat.com, jrocktx1 on all the social medias and that other stuff. We also love to hear from, and I see regularly some folks here in chats that join the stream from the community as well. So the Kubernetes Slack, so if you go to kubernetes.slack.com and join up there is an OpenShift users. That is, a couple thousand folks who are all like-minded and care about what's going on in OpenShift and OKD, of course, the stream. So both of us participate there, along with a number of others that have folks.
Hey, Andrew, your audio is kind of going in and out. It sounds like you're.
I'll bring the microphone closer to you. See if that works.
Yeah, it goes in and out. It sounds like it's kind of like you're in a tunnel a little bit.
Okay.
That's much better now.
I blame macOS.
There we go. Me too.
Yeah.
It's perfectly fine now.
Yeah, it's never my fault. That's
No.
Just like my 14-year-old, it's never his fault. Nothing is ever his fault. It is always someone else's fault.
Yeah, and just for Christian's awareness, everything else was fine. It's actually just Christian settings, so he just needs to mess with this stuff.
It's probably that I saw his tweet the other day where he's using an M1 Mac to like remotely connect into Linux machines. So he's turned a fancy laptop into what is basically a dumb terminal, right? He's got like a portable VT100 in his lap.
That's all you got to do.
Yeah.
Perfect hardware for it.
So Selwyn, don't put that evil on me. COVID's fault. Knock on wood. I'm not going to actually knock here because it'll reverberate through the microphone and everything. Actually, my family has almost entirely avoided COVID. Only one of my children got it. She self-quarantined, and the rest of us have managed so far. So let's hope that it stays that way.
Yeah, that's awesome.
Yeah. Let's see. Jason from Fullbar. Can you change CPUs.cfs.us on OKD OpenShift? If so, where's that setting managed? I think you probably can using something like a performance profile. Let me share my screen here. Share screen. Window. Oops. Come on. Quit jumping around on me. So let's share this guy. I want to go to the 4.10 docs here, and I want to go to the performance. Really? No? Oh, because I misspelled it. Performance. If we go to this performance profile and the performance profile, which is part of, where is it down here? Anyways, so we can use these performance profiles to set low-level things like that. So I think you probably technically can, but I would suggest checking with your account team, checking with support to make sure that it's something that is, if you're using OpenShift proper and not OKD, to make sure that it is something that is supported, right? Because we can, CoreOS at the end of the day, or Red Hat Enterprise Linux CoreOS is called RHEL CoreOS for a reason, because it's RHEL. It just happens to be using Rpmos tree. So you almost certainly can change that. The question is whether or not it's something that is supported with OpenShift proper. So, and I think, is it performance profile? Performance add-on operator. Yeah, that's what I was thinking. The two are related, but I was thinking the performance add-on operator, which allows you to go in and make like super low level changes to all those types of things. So. Let's see. So I do want to get to our top of mind topics and all of that other stuff. So Chendu, we'll address your question here real quick. I think. Did I miss one? Or I see you answering it, Johnny?
Mm-hmm.
Yeah. Oh, why operators fail an IPI process of installing OpenShift cluster on Vsphere. So there could be any number of reasons for that. I'll say that the most common one is when you see like the authentication and the ingress operator fail to deploy. That's because no worker nodes are able to deploy. So I call out your question specifically, Chendu, because one of my top of mind topics for today is Vsphere IPI and kind of why some of the things that it does. So machine API, which is really run on the control plane nodes, it needs to be able to talk to vCenter. So if you have like a separate network, there's firewalls or anything like that, just make sure that those nodes can communicate with vCenter, because with IPI, it's the control plane, machine API, that will talk to vCenter to provision those worker nodes, not OpenShift install. OpenShift install does communicate with vCenter to create the VMs for Bootstrap and for control plane. It also needs to communicate with the ESXi hosts, because it will upload the template VM, the OVA, directly to an ESXi host. But after deployment, I believe you can reclose that firewall port if you opened it up. But yeah, please keep the questions coming in. We'll talk top of mind topics while those are coming in, and we'll address any questions that come up as we can. Let's see. So we talked about no stream next week. So tomorrow at 10 a.m. Eastern is the What's New in OpenShift 4.11 product management live stream. So Johnny and I will be here. I think Michael Foster will be here, along with a number of other folks, helping to answer any questions that you all happen to have about that, and anything that we can't answer, we take those and we send them over to the product management team so that they can answer them. So if you're interested in what's new in 4.11, which that should also indicate to you that 4.11 release is coming up in the not too distant future, be sure to tune in. John and I will also be spending a number of episodes coming up. We haven't fully planned it out yet, talking about some new features in 4.11. So we've got, I don't know, we're up to like 4 or 5 different things that we want to talk about now, Johnny. So we'll figure out whether or not we need like dedicated episodes for some things, or we can combine 2, 3, 4 of them together and figure out how that looks. But yeah, look forward to our What's New in 4.11 for administrators live stream, just like we follow up all of the What's New streams with that type of information. Let's see.
And thanks to our Hope 9 for posting the link, for tomorrow. So it'll be good.
Yeah. I saw our Hope 9. I saw you also posted on Reddit and all that other stuff. I think I've seen you on Twitter as well. So yeah, we're thank you for your help with all the social media. That's important. And
better at it than we are.
Yeah, I'll admit that I am. Johnny was laughing at me earlier because we both were sending each other messages at like 10:20 this morning, right? Just a few minutes before the stream. Like, hey, did you do social media yet? No. Oh, okay. Well, which one do you want me to do? I'll do the others. So
teamwork.
So yeah, we do appreciate the help, and that's not to minimize the work that Stephanie has worked very hard with our corporate social media teams, as well as with the BU social media teams. Colleen, who runs the OpenShift Twitter account and LinkedIn and all the other stuff, she does a great job too. But yeah, it's just funny to me how Johnny and I are always like the laggards, and you would think that with we're the hosts, we should be on top of that, right?
Yeah. It's that celebrity mindset, it's starting to wear on us.
Yeah, sure, that's what we'll go with.
And so Stephanie's like kicking us into shins right now, Andrew. So we need to make sure you guys like and subscribe on YouTube and Twitch, so that way you get the updates, and just make sure that you're doing that so you know what's coming out and you get the content that we're doing.
Yeah, especially for the upcoming streams. We've been trying to be better about updating the streaming calendar. So if you go to red.ht/stream, that'll take you to a landing page that has a calendar, a Google Calendar that you can subscribe to. And we try to update all of the episodes with what the topic is. It's not always. Do we have a lot of advanced planning, we'll say. Sometimes we don't figure out the topic until like the day before, but when we do know it ahead of time, we try and do our best to update those. All right, let's see other top of mind topics. I think I had one more and you had a couple, Johnny.
Yep.
So I wanted to note that, and I actually saw this over on Reddit. So Gateway API has been officially released as beta in upstream Kubernetes. I know we normally don't talk about upstream things. It will be a while before any of it is relevant to OpenShift and stuff like that, because once it hits beta is usually when we begin evaluating how to productize it, how to incorporate it into OpenShift and all that other stuff. But this one I feel is going to be an important one, and it's a pretty significant change in how ingress and a number of other things are done. So I would definitely encourage, anyone who is interested, who cares about ingress and all that with their cluster, to start paying attention to what's going on with Gateway API. So I will, let's see, let me find Twitch here. So I will post this link to the Kubernetes SIG for Gateway API into the Twitch chat. So that way it gets rebroadcast across all the others. And I will also post a link to the blog post over on kubernetes.io that talks about it. So, kind of nothing for right now, more of a, hey, heads up, this is going to be something that's big and important in the future. And I think that we should start paying attention to it. And when the time is appropriate, of course, Johnny and I will dig into it and dive deep.
Mm-hmm.
Let's see. The last two things here are, I think, from you, Johnny.
Yeah, just updates. Like I was looking out on the blog website this morning, and I noticed that there was a blog for what's new in Red Hat ACS. So for all of you security-minded folks, it's a pretty good blog, just kind of going over some of the new features that are coming out. And a shameless plug for an episode that we have coming up in the first or second week of August, where we're going to have somebody from the ACS team come out and demo ACS and talk about the capabilities that are coming with that product. So just keep that in mind. If you're not sure what ACS is, it's a container scanning software. It does a lot more than I'm really doing a terrible job of selling this, but it's a very inclusive product that comes with Red Hat. That's part of the Platform Plus subscription. But just keep an eye out for that stream that's coming out, and check out this blog for so you can see what's going on with it. And then the other one. And I'm sorry, I'm trying to talk and do things at the same time, which we know is a struggle. The other one is there's another blog on OpenID Connect. So if you watched a couple weeks ago where we did the OpenID Connect in the OpenShift, using Keycloak as well as just GitHub, there's a couple blogs out there that are showing just more detail on that. And we'll have our own blog on what we did as well coming up. So those were the two things. And then one thing that I just thought of as I was looking at Christian's response earlier is that his book is out now. So if you're interested in learning about, I think it's called Getting GitOps, it's available now for download at developers.redhat.com. So go out and check that out. And congratulations, Christian. That's a pretty awesome achievement.
Yeah, I think I've said before that having also co-authored a book before, that is it's quite the undertaking. And looking back, right, rose-colored glasses and all of those other things, it's been slightly romanticized now after 7 years. I also remember the massive amount of work that it was. So congrats, Christian. All right. So I realized that I kind of jumped ahead here, right? Normally we, Johnny and I banter a little bit, and then we introduce the topic and we introduce our guests, and then we do the top of mind topics. And so my apologies to our guests today. I alluded to y'all earlier. So I'm very happy to be joined by two of the folks from my extended team. So Henri and Diego. Henri, I'll ask you to introduce yourself first.
Thanks, Andrew. So I'm Henri Montenon. I'm a field product manager. We're indeed from the same extended team. I take care about all the edge and hardware enablement topics.
And Henri and I have been working together now for like a year or so, and I usually rely on Henri for like all of the super hards, like Ansible type things, and he created a whole set of scripts to deploy like an OpenShift all-in-one cluster, like take a single physical node and deploy a whole bunch of, either one single node OpenShift or a full OpenShift cluster, and like automate the deployment of ODF and all this other stuff. So Henri, don't understate. I would encourage you not to understate the amount of effort that you put into those things. And it's been super helpful.
Well, to be fair, I come from consulting, so I do like playing with labs and that kind of stuff. So
yeah,
that's kind of my go-to stuff.
Well, thank you for your help there. So we are also joined by Diego, and Henri, you're in France, and Diego, I believe you're in Spain. So my apologies for asking you earlier. Like it was kind of noisy, and we said, "Oh, do you mind turning off the fan?" And then like, "Oh, but it's so hot there. I feel so guilty asking you to do that."
Yeah, no worries. It's difficult to work here with the windows closed, but it's something that we need to do. So yeah, thanks for having us today here, and let us just came here and talk about MicroShift. So I'm Diego Alvarez. I'm from Spain. As you said, I'm part of the customer and field engagement team as a technical product manager. I'm focused on edge technologies. Yeah, I don't know what else to say. Well, I joined Red Hat 6 months ago, so I think I'm still brand new here in the company. But yeah, I studied telecommunications engineering here in Spain too. Previously, I've been working on the cybersecurity side, also with identity and access management. Yeah, that's pretty much all.
Yeah. Well, welcome to the stream. We're happy to have you here. And 6 months in, so it's still a bit of a fire hose, I would imagine.
Yeah. Still, I'm trying to learn some new things. There are a lot of different technologies, products, so we are getting into it.
Yeah.
Good luck.
Yeah. I think it took me the better part of a year before I really started feeling like I understood what was going on. Right.
Oh yeah.
Yeah. Well, as we kind of mentioned before, and I think as both of you have said, today's topic is around MicroShift. And, we've talked about MicroShift before. We had a couple of the engineering folks on. I think Reese talked about it last week briefly, right, as kind of how it fits into the overall strategy. And I thought, when the opportunity to have you all on to showcase this, Johnny and I both, I think, almost literally jumped up in excitement because it's really one of those like the proof is in the pudding type of things. I hope that turn of phrase translates well. So it's a proof of concept, right? It's a visible way that we can see exactly what we mean when we talk about MicroShift and how it fits in and all that other stuff. So I don't want to spoil anything here, but I know that we're going to be looking at a machine learning. I say machine learning. I don't know if it's actually machine learning or AI, but an application that's running on an edge device using MicroShift. So I'll kind of hand it over to you all from there to tell us about it.
Okay, so yeah, actually we have prepared some slides. So if you want, I can share my screen quickly. Let me know if you can see it.
Yep, looks good.
Good to go.
Okay, perfect. So, well, this set of slides was presented by Henry a couple of weeks ago, I think, on the Opencv Commons in London. But we can use it to illustrate what we want to say. So, the main part here will be the demonstration, but we wanted to give you some background about MicroShift and why it's important in our architecture. So yeah, I don't want to be here just talking. So if you want to add something or if there are some comments or whatever, just raise your hand and we will answer them. Okay. So basically, I want to start talking about edge computing with Opencv. Well, nothing new here. Basically, Opencv is about delivering applications anywhere. And when we talk about anywhere, also we are talking about edge. So it was built on top of three main pillars. One of them was consistency for IT or developer teams. They have their existing architecture and they want to scale it, so it's quite easy with Opencv. Also, another one is flexibility. When we are talking about edge, sometimes it's difficult to give a specific definition for it. So, for example, edge could be different from one customer to another, from one person to another one. So we needed something that gives our users the flexibility to choose what they want. And well, as you can see, the third one is choice. Here we want to give the opportunity to choose on what Red Hat, our partner ecosystem, which product or technology works better for deploying applications. So yeah, nothing new here. Don't know if you have any questions.
I like that you pointed out there that edge can be many different things. I've worked for organizations before where there was kind of a central location that was, the core, right, the data center, and then everything else they considered the edge. even though in some cases those edge sites were as large or larger from a compute and resource perspective than that core data center. And then of course, it went all the way out to like, in vehicle things and stuff like that, that were truly, remote disconnected edge type of things. So edge doesn't have to be, ultra small, disconnected, type of scenarios. It can be a whole lot of different things.
Yeah, exactly. It could be wherever you want to compute some data. You don't want to send it to your central core cluster. So yeah, everything that is processing data on the field could be edge devices.
Yeah.
So well, here I saw last episode, and I think that Rickard Oxenham was talking about the Opencv architecture for the edge. So we can skip this part really quickly. So we have 3 different options depending on the use case. One of them is single node edge servers that gives you really low bandwidth and works pretty well with disconnected sites. So here what we are doing is just deploying a single node on the far edge with both control and worker capabilities at the same time. Another option also is a remote worker node. So it works on environments that are very space constrained. So here we are deploying a worker node, but it's managed from the regional data center. And the last one is the 3-node cluster, which give us the most similar experience that we could have with Opencv on traditional architecture. But here we have 3 different nodes, also with control and worker capabilities. And yeah, that gives you high availability, while we are keeping in mind that we need to reduce the footprint because we're talking about edge devices, which typically are low in resources.
So I want to pause there, if you'll go back for just a second.
Yeah.
And I know this is one of the core topics or core principles from last week, which is kind of all of these edge architectures, all of these edge things. So kind of ranging from, and I think what's missing here is the very top and the very bottom. So very top being MicroShift. And I think it's missing because, well, it's not a Red Hat product. Right. It's still an open source project. It's still a community project. It's just one that is really interesting, and you're seeing a lot of activity from us around. And then at the very bottom, right, is just a regular cluster. There's 3 node clusters, and then there's the 5+ node clusters that exist inside of there. So Selwyn had a question a little bit earlier that I wanted to, because remote worker nodes is on the screen, I'll take the opportunity to talk about it. I was asking about some best practices or some other documentation around remote worker nodes. So I don't know that there has been anything published on the blog. Johnny, I don't know if you know of anything off the top of your head. I don't.
And I'm asking back channel too. So
okay,
no, I'm not aware.
So yeah, generally speaking, those practices or anything like that are going to be dependent on your application. So for example, you say here that details on how to keep the VIP traffic routing correctly in case the route site loses network connectivity. So it's going to depend on a number of things. One being what's hosting each one of those, right? If it's in a hyperscaler, does that hyperscaler have something like a global load balancer that can simply redirect to one of the other quote unquote remote sites? Are those ingress controllers, are they hosted in the same location as the control plane, which means that there can be other bigger problems that are happening there at the same time. It could be solved other ways. So, for example, having a sharded or a sharded ingress or multiple ingresses with different ones hosted at each one of those remote sites. So there's a number of different ways you can address that. I wouldn't say any one of them is better or worse than the other. It just depends. And we'll see if we can dig up some information on that. So sorry to interrupt you, Dave.
Yeah, no worries though. So, well, here we have at the right side what you were talking about, the typical core data center. So here we are trying to map all these architectures into our different edge tiers that we have. So we're starting on the right side with the core data center with 5 or plus Opencv nodes, down to the edge server. So basically on this range, you can use different architectures for OpenShift. Even on the edge server, we could have maybe a single node OpenShift or a remote worker node. But the problem here is what happens when we have smaller devices. For example, we have another two edge tiers, the edge gateway and the edge endpoint. For example, at the edge gateway, we could have a remote worker node, but at the edge endpoint, we have really little or tiny devices. So we have to provide a solution for that. Here we have some examples of those really small devices. For example, we have IMX, we have Jetson, and on the right side you have Intel NUC. So what solution we provide for all of them? And we are providing RHEL for Edge. So yeah, RHEL for Edge is the operating system for the enterprise edge. Among some other benefits, I highlighted 4 of them. So the first one is quick image generation, where basically you are using image builder tools for building your own operating system built on purpose for your architectural challenge that you're facing on the edge. Another one could be, of course, management at the edge in a secure way. We have zero-touch provisioning. We have also FIDO that I'm going to talk about it later. And at the bottom, you can see efficient over-there updates and intelligent rollbacks. This is an advantages that came from using Rpmos trees. So it's way easier to perform an upgrade or a rollback if something's going wrong. So yeah.
So Diego, can you talk about any of the differences between RHEL for Edge and RHEL CoreOS?
Well, I don't know exactly. Maybe I cannot give you an answer for that. So I don't know if Henry have some background.
I mean, I can talk at a high level about it, but
Okay.
it would be interesting to know some more. Maybe Johnny, maybe you and I can follow up on that if I'm
Yeah,
able
that's fair.
to where. So one, I think the important thing to note is so RHEL for Edge is RHEL, like RHEL. It is managed, it is deployed as using Rpmos tree, which sounds and looks and tastes a lot like how CoreOS is managed, right? I think the biggest difference is that CoreOS, everything is a container, right? Basically, it is only what is managed as a part of that base operating system through Rpmos tree is only enough to get like kubelet and Creo and containerd and or cryo. Everybody always corrects me to cryo. I don't know why. Basically only enough to get containers running, and then literally everything is a container inside of that operating system. RHEL for Edge, you can certainly do that through something like Podman. And creating, systemd units to start containers and stuff like that. But that it's not intended to be, done like that. It's more like a traditional RHEL operating system. You need to install packages, you install them into the Rpmos tree layer, and then you can deploy it out to that using whatever tools are available to you. I'll also add that, and I think we'll probably talk about this more in a moment, the management principles are different. Right. RHEL for Edge, you use the fleet management tools, you use Ansible automation platform, you use all of those types of things to manage it in kind of a very close to traditional RHEL type of method. Whereas CoreOS, RHEL CoreOS is only available through OpenShift. And it is intended to be managed through OpenShift using machine config operator and all of the other mechanisms inside of there.
Okay, yeah, thanks for the information, because I didn't know exactly the difference. So yeah, that was useful. So I mentioned Rpmos tree. So Rpmos tree, it's inside RHEL for Edge. It's not something new. We already implemented it a long time ago, even before CoreOS. So I think it was with Red Hat Atomic operating system. I think so. So basically here we have operating system based on immutable binaries and libraries. So it's also based on transactional updates from A to B, which means that if you want to perform an upgrade, you need to make it in one single step altogether. So it makes everything more easy. Also, we don't have in-between state during the update. This means that you can, for example, perform an upgrade in the background, and then you can apply it just rebooting Node. Also, another good thing is that now migrations from RHEL 8 to 9 are support, and it enables seamless major release upgrades and rollbacks. And the last thing that I want to show you is FIDO device onboarding, also known as FDO. We were talking about it when I said that we can manage everything at the edge. So this solves the problem of late binding device to your edge platform. Basically, you have zero-touch provisioning by deploying devices on your factory plant. Then you can pre-configure everything, ship them into the edge, and just plug into your management platform, and it works. So this was implemented in RHEL 8.6, and also it's available, of course, in RHEL 9. And here I wanted to just summarize what I've been talking. Of course, this slide is quite similar to the one that I saw at the beginning. But if you see at the top, we have added the small footprint edge operating system. That's RHEL for Edge. So it works for memory constrained servers and just needs 1 core and 2 gigs. So if we compare it to the smallest one that we had before, was the remote worker node with 2 cores and 8 gigs. So yeah, quite low, the requirement for that. But maybe you're asking, where is MicroShift here? You asked that before. So that's why we are here, because maybe we could have a remote worker node on the edge, but we don't have the connectivity to the data center. Another option could be using single node, or devices are not enough, talking about hardware resources. So that's when we wanted to take Opencv further into the edge with MicroShift. So yeah, I don't know, do you have any question on the chat maybe?
No, I don't. Let's see. English asked about 2-node cluster, which we answered in chat. So short version is, on the roadmap, there is going to be the opportunity to take a single node OpenShift, which is a 1-node control plane and worker, and then add additional worker nodes. But it would still be a single control plane node with additional worker nodes. But there is no intention, as far as I'm aware, to have like a cluster that has 2 control plane nodes, because etcd just wouldn't function, right? It can't establish quorum.
Okay, so Henry, do you want to continue with talking about MicroShift?
Sure.
Okay.
Sure. So basically, this is where Red Hat Emerging Technology comes into play. So Red Hat Emerging Technologies is part of our Office of CTO. They're working on technologies that are still taking shape in the enterprise or research communities. You can find all their projects on next.redhat.com. All the work they do is completely upstream and community-based. They often work on existing community projects. They also often create their own, which are made available on their public GitHub. Not everything they do is followed by products. There's actually quite a lot of things they've been working on that never happened as products. They have also multiple areas of focus, as you can see. So there's cloud storage, edge, security, data and AI, quantum computing, even all kind of stuff. Next slide, please.
All I'm hearing is OpenShift on quantum computers. What?
Yeah, well, that should come pretty sooner than later.
I thought I remember somebody talking about I think it was IBM had like a API where you could reach out and make requests, schedule things on quantum computers, and somebody was like, "Oh, is there an operator for that?" No, I don't think so.
Not yet, but hopefully we'll get there at some point. So what exactly is MicroShift? MicroShift is an experimental flavor of OpenShift that's optimized for the device edge. It's basically OpenShift, not just Podman running on RHEL for Edge, that provides you with standardization for your software lifecycle, consistency for your DevOps across all your footprints, and it can be, of course, managed by an orchestrator, such as Open Cluster Management or Advanced Cluster Manager. It's also designed to leverage an edge-optimized Linux OS, so all the advantages that Diego just talked about. It is meant to be using feeder device onboarding to be configured and set up with zero-touch provisioning. It's meant to use the Rpmos 3 transactional updates model. It is distributed as a single binary that can be deployed either as a package or as a container on your existing container devices, basically container running devices. So it allows you to make fully customizable OS image already embedding your MicroShift. It really aims for a very low resource footprint. It aims for 2 cores and 2 gigs of RAM as a minimum for your devices. It does support currently both AMD64 and ARM64, but it can easily be extended to RISC or other kind of devices. It's very small in terms of payload, so you don't have much to download or update over the wire. And it got very low storage requirements. Right now, I believe it's in the 4 gigs space.
So a couple of things here. Is the best way to describe MicroShift something like kind, right? Kubernetes in Docker, where it provides the Kubernetes API as a container image that is then run inside of Docker. So it looks like, sorry for banging the microphone, it would be the same or similar to deploying, kubelet and all of those components directly on the operating system, but instead they're in containers, or is this different than that?
Well, it kind of provides the option to run like KID would, because you can have it as a container that you then run with privileges, and then you can manage your CRI-O, etc. We also have the option to have it as a binary, so then you don't have to have a privilege-enabled container running there.
Mm-hmm.
So
and
options are there.
And I also, I always like to point out that MicroShift isn't OpenShift. It is, but it isn't, right? And the reason why we don't call it micro OpenShift or anything like that is because it doesn't have the full set of things that make OpenShift. So, for example, there's no OLM.
Yeah. So that's where I was coming actually with my next slide. What actually differs between OpenShift and MicroShift? So OpenShift is really meant to run on cloud providers, bare metal, VMs, you name it. But it really needs to be able to have some control over both the operating system, which is RHEL Core OS, and the underlying hardware. So this is basically provided by cluster operators that we decided to tear down from MicroShift because we don't need to manage the underlying systems because that would make it, first, we are using small devices there into the edge. We don't have any BMC. We don't have stuff to manage there per se. So there's no point in having to use cluster operators that takes a lot of memory, etc., when you don't have anything to give them to manage. Also, we don't see MicroShift as something that you would go and install on AWS, Azure, etc. It's really meant for small edge devices. So nothing really to manage. Also, those edge devices usually need to have very specific driver sets, which makes it pretty difficult to have them integrated with RHEL CoreOS, because you then need to modify too much of the underlying operating system for it to really stay manageable by OpenShift. So again, no point in having a CoreOS that we would manage with cluster operators. So MicroShift really is just the Kubernetes components that you need at minimal to have a Kubernetes cluster, basically, well, a one-node cluster.
And we've got a couple questions. Go ahead, Johnny.
Yeah, I was just going to say the same thing. So Jason from Fullbore asked, are MicroShift nodes under the control of a normal OpenShift cluster, or are they separate cluster managed by ACM?
So they would, in this case, be separate clusters, because if you have several nodes, then you have several clusters, and you would, of course, be able to manage the workloads with ACM.
But you don't necessarily have to have ACM to manage that cluster, right? Like MicroShift could be completely independent and on its own. Right?
Yeah, it can be completely independent and managed as any Kubernetes cluster, basically.
Awesome. And then Christian says that he wants a multi-cluster MicroShift.
Well, that might happen someday, but not right now.
Christian, I know you've already gone through the pain of deploying OLM on MicroShift, so I'm expecting to see a pull request for multi-cluster from you anytime.
Indeed.
And Dwayne also asked about any compliance needs for MicroShift.
I don't get the question.
I think, and Dwayne, please feel free to correct or clarify. I think you're asking whether or not there is specific compliance requirements or compliance needs associated with MicroShift, or maybe even compliance profiles. My interpretation is that this is the way that it's done today is it's going back to the OpenShift 3 model of you're managing the operating system independently of the Kubernetes on top of it. So you would apply, hardening rules and all of those things for whatever your compliance standards are to RHEL for Edge. And then if you need to further, harden the Kubernetes MicroShift on top of that, then you would take actions at that level. But I don't think, you clarified their profiles. Yes. So I don't think we've published, it's not a product yet. It's still a project. So there's nothing like compliance operator or stuff like that that's available for it.
Yeah, not at this point.
Yeah. Does MicroShift need 2 cores for far edge with worker plus control plane, reduced number of required cores? I thought we had a slide that had resource requirements.
The minimal requirement for running MicroShift, so that embeds the, of course, worker and master, which are running on the same node. So, yeah.
Yeah, Mark, thank you for the help, Mark. RHEL compliance would follow MicroShift. Yeah, that was kind of my thought as well, is that would be done at the RHEL level, or RHEL for Edge. And to be clear, you don't have to use RHEL for Edge with MicroShift. You can use regular RHEL, RHEL not for Edge, RHEL for data centers. No, let's not go back there.
Actually, right now with MicroShift being a community project, you can pretty much use any flavor of Linux. I myself, during the demo that's going to follow, using the NVIDIA Linux distribution that comes with the Jetson, because that's the only way to get 3D acceleration right now. So.
Nice. I wish I had a couple of Jetsons in my home lab myself, but all right, I'll stop interrupting you. For anybody in our audience, please keep asking questions. We're happy to answer those.
Yes, please do. So what does MicroShift do also is enabling flexible usage models, where you can either have your OS system image which would be embedding MicroShift and your operating system, which would be connected to the network, so you can then talk with device management software and have an application management software as well that would then point it to the Kubernetes applications to run. Or you can have a model that's fully disconnected, where you have your USB key embedding your operating system, MicroShift, all your Kubernetes application that needs to run, and then you can send updates to the factory in the form of USB keys that would be plugged and perform the update of both the operating system and potentially applications. So this MicroShift project, actually, our friends in IBM liked it so much that they decided to send it into space. I believe these have been presented many times already to you guys, but yeah, this is the Endurance project. You're welcome to go and register. I don't know if they plan to open it to others than educational purpose at some point, but you never know. And now it's demo time. So let me share my screen. So this is my little Jetson running MicroShift. So right now I only have the core MicroShift running. Let me make the window a bit bigger. Hope everyone can read correctly.
Yeah, that looks good. Thank you.
So this is just plain MicroShift. I'm going to start some Opencv workload there. So computer vision, I'm using small cameras, very tiny one, ESP32 type. So first I am gonna start my Wi-Fi server because I need to connect those cams to my cluster. So let's also have a look at the camera connecting. Just to make sure everything works before we start the test. Okay.
What kind of Jetson are you using? Are you using a Nano or are you using one of the more higher end?
Well, I got the higher end AGX, but this would work on a Nano as well. This has been tested on Nano and NX as well.
Awesome.
This is actually all available on the Emerging Tech GitHub. You can find the whole demo, which is AI4H MicroShift demo. It's all there for you to try if you want. And there are even bits to make it work on a Raspberry Pi, actually, if you don't have it yet. So now we have our camera connected. Let's apply the computer vision server because we want to do something with these pictures. Oops, taking too fast. So here we should see the camera registering. Let's give it a bit. Oh no, I need to expose it first.
And for those that can't see behind our beautiful faces, he's just running OC expose on the service to make sure that the route's populated. So.
So now we did create the root service. And now actually our camera should register. So now we can see the camera is being registered. And we can grab a browser window. That should now be getting our camera feed. And as you can see, you can now recognize me. You could actually, well, I don't see your faces anymore. How can I recognize you?
It's oh, Stephanie, can you turn back on our images on the side? Because I said on social media that Johnny and I provided our images, so let's see if we break the model.
Please don't break on me. Please don't break on me. Please don't break.
Oh, it's a bit small.
Oh, here it is.
So OOBEE, your question there, would you mind issuing an OC get CO? So that actually won't return anything because there are no cluster operators. Hey, it recognizes me. So there is no operator lifecycle manager. There is no CVO that's deployed or cluster version operator that's deployed with MicroShift. So all of those operators that show up with OC get CO are the ones that are managed by cluster version operator. And since there's no CVO with MicroShift, therefore those don't show up. I don't think that CRD even exists.
That's it. The resource type doesn't even exist.
Yeah. Let's see, Shrikant. If there are any upgrades to binary, then do we need to wire the whole binary to edge devices? Maybe. So I think in this instance, the application is deployed as a pod. I don't want to speak for you, Henri or Diego. So in that instance, you would be, when you go to update the application, you would be pulling down a new container image and whatever's inside of there. But
so in my case, I'm using the binary version. So basically, the binary itself, as you can see, is only 144 megs. So that's what you would need to update. It will, of course, it will download. Well, actually, no, it won't download anything. This binary can work offline. So it's not so big.
So, yes, maybe. I think it's the answer.
Well, I believe that there should be a way to actually update the image of all the pods individually. I don't know that it's currently possible though.
Yeah, this I think we're going to see some more about how to manage, Rail for Edge devices, MicroShift, and the applications and services that are running in there, coming out of various teams inside of Red Hat as time goes on. Especially for as we get more comfortable, more familiar with how to do this for very remote, very low bandwidth type of scenarios. To your point, 144 megabytes isn't a lot unless you're on like a satellite link, and you're getting dial-up speeds, because it's that's reality in some places. I'm thinking of like cruise ships or other things out at sea where you have very little bandwidth, and you still want to be able to do those.
Indeed, and that's also where the possibility to have it fully disconnected and managed by an Rpmos tree that we can have on a USB key or SD card or whatever makes it also convenient for those kind of use cases. I mean, if you can send someone with like small SD card or sending by post or whatever, then you can sort those issues as well. But yeah, They will need to be, to get those 100 megs there.
Yeah, the Ansible team, Ansible automation team, had a really cool demo that I saw recently where that's kind of what they're doing. They're using OpenShift in a full deployment to do app dev and sort of outer loop activities, right? Basically generate a container image with the application, and then they take that and stick it on a thumb drive, that container image, and then they take it out to one of those locations, and it uses Ansible automation platform to go through and push configuration updates and platform updates and application updates out to all of those nodes. And the tech doesn't have to really do anything, right? They plug it in, they start the interface for Ansible automation platform, they click the task, and go get a coffee for 20 minutes, come back, pull the thumb drive, and move on to the next one.
Yeah. And that's exactly what we're aiming for there.
Yeah. All right. So this has been fascinating to me. It's always interesting to me to see these different kinds of use cases. And I know we've had, on the marketing side of things, because for a long time I have technically had marketing in my title, so I try and stay aware of what's going on. Right. We've got a lot of industrial edge and stuff like that. Use cases that we've talked about. And Johnny, there's even isn't there a validated pattern that uses something like this to do image recognition for different things?
Yeah, there is. It's we've done one for medical diagnosis, which is doing object detection for pneumonia. We've done industrial edge, which is like sensor monitoring and stuff like that. So there's a bunch of capabilities. I was super amped when you're talking about coming on and doing this. This is awesome.
Yeah, and I'm thinking of all the ways that we're effectively modernizing application, not just deployment, but development in many cases. And that's really cool to me. So this has been really enlightening to me. For our audience, it is a little bit after the top of the hour. I want to be respectful of Diego and Henri, who are in Europe, and it is both the end of their day. We're standing between them and dinner, or maybe a pre-dinner beverage. And as well as it's hot, and I don't want you all to be cooped up any longer than necessary.
More like getting some freshness.
Have a lemonade or something like that. I won't make any. Us Americans love to have be stereotypical about Europeans and ice. Like Americans love ice in our drinks, and Europeans it's not very common. And I won't be stereotypical.
If I could, I would just like to ask one question about the application. If you could give a 30-second, hey, this is what it is. And mainly, we talked about it a little bit yesterday, and you're saying it's based off of clear vision, right? Can you kind of give the elevator pitch of what the app is on the back? I mean, obviously it's doing image recognition through the camera and stuff like that, but how's the app put together? How's the modeling working? How are you doing all the training? If you can do that, that's a really good question to try and have you do it quickly, but.
Well, let me share my screen again then. It is really using some samples of computer vision in Python.
Clear vision. Sorry.
Yeah. So most of the logic, actually, all of the logic is just there. So we have a first step where we do basically feed it with the pictures to teach him to recognize different people. And then we have, just a little bit of code. First, we resize the picture because, even with GPU acceleration, treating full-size pictures is a bit too much for this kind of smaller devices. Also, we wanted to have it working potentially with Raspberry Pi without acceleration. So here we have CNN basically tells it to use the hardware accelerated version of the face location from Opencv. And we're just basically using basic Opencv methods there to try and recognize there is a face first, then match it against the faces we know, and then we do add the small name box. The other components of that are basically the Wi-Fi access points that will provide that will provide first and last AP configuration, basically, and that will push some information into MDNS to the camera to provide it to a point where to register. And there's the third component, which is some code running on the camera itself, because that's ESP32. And I don't think I have a formula set up there to show it to you, but we can look at this. So this is responsible for basically telling the camera that it needs to connect to the MicroShift cam server using the information it will be getting from the Wi-Fi AP server. That's pretty much it.
Awesome. Yeah, the reason why I wanted you to kind of like walk through it, because I think it's important for people to understand, like, this, what you've done is you've done one model that's doing image recognition on faces and pictures, right? But then if you think about it, you've got a camera hooked up, so you could have a camera hooked up outside of your door and looking for wildlife or looking for certain things, right? So there's all these things that you can do that don't necessarily have to be like facial recognition, but they could be object detection or something else, right? And then you can stream that in and you can put your model and you can train your model and then use a tool like MicroShift at the far edge to kind of like execute that model and then it's essentially report back and then retrain. So there's this like whole workflow between OpenShift at the data center and then MicroShift at the edge that you can have implemented and then have just like this nice continuous loop of, the model being deployed and then the model being trained and then, ultimately fed back into the edge. So I think it's really awesome what you guys are doing with this. This is insane.
Yeah. Yeah, that is indeed quite a good example of using the camera, which is basically an IoT device that you can program as you will to just send pictures. I could also do some transformations directly on the camera if we wanted to, like turning the image around left or right or upside down if your camera is positioned in a non-standard way. That's basically proper edge scenario where you have these edge devices that's providing connectivity to your IoT device, getting data from it, processing the data locally, and then you can do whatever you want with the data.
Yeah. This is exciting. It really is. It's because we're opening the can, right? So we've had these ideas for a long time of like, man, would be cool if I could do this, and now we're getting that capability and we're able to put it in people's hands. And I think that this is just going to be awesome. I think that the doors that are opening with MicroShift, I'm really high on MicroShift, by the way, if you can't tell. Like I'm super excited about this. But yeah, I think the doors that are opening with this it's going to be awesome. And the tech that's going to come out is just going to be incredible to see.
Yeah, Dwayne asks about whether it can be done on a Raspberry Pi, and MicroShift will run on a Raspberry Pi. I don't know about the machine learning part because there's no acceleration like with the GPU on a Jetson.
So this demo does work on a Raspberry Pi. It is a bit slow. I mean, you wouldn't get as many frames per second that I did just get with the Jetson using GPU. But it does work, and it does work pretty well, actually.
Yeah, I'm curious, well, you can do MicroShift on, Raspberry Pis and stuff like that. Usually when folks ask about that, at least on our stream, it's usually because, well, I want to learn OpenShift, right? I want to be an OpenShift administrator. And the MicroShift admin experience is, I'll just say, nothing like OpenShift proper.
Yeah.
So that just a fair warning there. It's not to say it's not worth learning how to do rel for edge management, getting familiar with Ansible automation platform, MicroShift and ACM and how all of that works together. There's tons of stuff to learn there. It's not OpenShift. So,
But in all fairness, it is still Kubernetes, so there's still some stuff to be learned this way.
Yeah, that's absolutely true.
Yeah, if you fundamentals, right? If you're trying to get your baseline, like your deployments and all that stuff, then yeah, definitely. But like Andrew, I get exactly where you're coming from, right? If you're trying to learn like how to deploy operators and stuff like that, probably not the tool you want to use.
Yeah.
So just a few minutes left. Again, I want to be respectful of Diego and Henri's time. So any questions that y'all have out in the audience, please feel free to send those in. We'll do our best to address them. If anything comes up afterwards, if we missed your question, we didn't answer your question well enough, if you're not watching us live and something comes to mind, don't hesitate to reach out. So if you're on YouTube or one of those, you can always leave us a comment. I now have a little script that runs a couple of times a day that tells me when new comments appear. So don't hesitate to leave comments there, and we'll do our best to answer those. Or you can always connect with us via email, andrew.sullivan@redhat.com, or Johnny, JONNY, @redhat.com. And of course, social media. So at Practical Andrew on Twitter, on Reddit, on all of those, and at JRockTX1 for Johnny. And last but not least, the Slack team. So I've been trying to get better about encouraging folks to go over to the Kubernetes Slack channel and look for OpenShift users over there, because that community really is great. And it's not just Johnny and I, right? There's a ton of folks over there who are willing to help, not just with upstream OKD, but also with or upstream OKD and Kubernetes, but also with OpenShift as a whole. So don't be afraid to take advantage of all of those tools. With that being said, if you haven't, and if just a gentle reminder, please subscribe to the channel. It's a great way to stay in touch and be aware of what it is that we're going to be talking about and when, as well as some other things that are happening across live streaming. So GitOps Guide to the Galaxy and the Level Up Hour and the What's New and What's Next, right? The What's Happening and the roadmap presentations for OpenShift are all broadcast through there. So. And I don't see any other chat coming in, so yeah, that's all I got. Johnny, Diego. I'm saying Diego and looking at Johnny, so that's why my mouth and brain didn't agree. Diego, Henri, thank you so much for joining us today. We really appreciate it. This has been just absolutely fascinating. Like Johnny said, I'm a fan of MicroShift and all of the possibilities that are going on there, and I'm constantly learning about it as well. So. This has been really helpful for me to really see an implementation, to see what it looks like and see how we can take advantage of all those things. So thank you again for joining us. We really do appreciate it.
Well, thanks a lot for having us, giving us the opportunity.
Yeah, thank you.
Yeah. As always, thank you in the background for Stephanie for all of your help and keeping us organized, keeping us on task and on target. And Johnny, thank you. Thank you for joining me every week and for covering for me when I'm gone. Yeah, man. So with that, I'll leave you with last words, Johnny.
Yeah, so just ditto what you said about Stephanie. Stephanie, you make us awesome. But I also want to say thanks to Reese too for actually positioning Diego and Henri for us, because Reese kind of approached us and was like, "Hey, you guys got to listen to this," and I'm so glad that he did, because this was great. I am super excited with you, Andrew. I think that, like I said, once MicroShift gets out there and people start using it, like the doors are just going to open up, and there's going to be some cool tech that comes out of this. So thanks again, guys, for coming on. This is really awesome, and I'm going to try and get my Nano out of the box and install MicroShift on it.
All right. Well, we will see you all in 2 weeks, but don't forget that tomorrow is the What's New in OpenShift 4.11 live stream at 10 a.m. Eastern.
Okay.